Yeah, so I worked at EMC for about 12 years, and then I worked at NetApp for about 3 years, and Red Hat Storage after that. And now I work at Portworx. Actually, I worked at CoreOS also. And now I work at Portworx doing containerized storage systems. So one of the things I want to talk about is that there seems to be containers and storage is kind of still new to a lot of people. So I wanted to kind of talk about it a little bit and kind of, talk about the differences, especially against comparing against virtual machines. So one of the things I want to talk about, I have a little list here of questions that if you don't have any questions, I'll ask myself. I'll be like, hey, what do you think about this? And then I'll answer, So one of the first questions is, how is storage in containers different than for virtual machines? Anybody know? All right, okay, here we go. Yeah, absolutely, there's a huge difference. So what happens is, let's go first with what is a virtual machine and then what is a container, okay? So first is that a virtual machine is a hypervisor running on a host, okay? And the hypervisor is the one that creates a virtual machine, meaning to the host that's running inside that virtual machine, it thinks that it's running on in real hardware, but it's all emulated. The memory is emulated, the networking, the storage, and everything. So it is when the virtual machine talks to the storage, what it's actually talking to is the hypervisor. The hypervisor can then go over the network, for example, over Fiber Channel or iSCSI or any other model that you would like, and talk to a storage system. Okay? Now the difference is a container is not a virtualized environment. A container is just all it is, it may surprise you, it's just an application that has been reduced its resources, okay? So it's just an application like anything else running on the host. It's not emulated in any other way. It's just that its resources have been reduced. So what that means is that when the container talks to storage, it's not talking to some other layer that then can go over the network and get your storage. No, it's talking to the kernel on your host. Okay? And because of that, there's a huge difference how virtual machines can access storage and how containers access storage. The biggest thing is that containers, when they access storage, they're accessing it through the host. That means the host must have all your drivers needed to access your storage. It is accessing it through the kernel. And if you've used OpenStack, anybody used OpenStack before? Yeah, all right, good. So if you've used OpenStack before, you use most likely a virtual machine used by KVM or QEMU. And what happens when you do that is, let's take, for example, you're using Ceph as a storage system. You would run your virtual machine, and then the virtual machine will talk to QEMU, the hypervisor, and then it will go over the network and talk to Ceph. It wouldn't even hit your kernel on your host. Right? But now, as a container running on a host, you need to make sure that if you want to talk to that same storage system, the host needs the drivers to talk to it. Okay? It's a big, big difference. All right? All right. So, does anybody know here what block storage is? File and object. All right. Just a few. All right, cool. So, did you know that in virtual machines, when you access storage, most of them are looking for block? Why is that? Because when the virtual machine looks for block and gets attached to the virtual machine, it formats the file system inside of it. So if you have a Windows machine, for example, a virtual machine, and it's talking to a storage system, it wants block because the kernel inside that virtual machine is talking to that virtual disk as if it was a real disk. So, and disks are block, okay? But containers, like I said before, are talking to the host, all right? So what that means is that the container cannot talk to a block system. It can't. It needs a file system, right? So what that means is that when a container application like MySQL or anything else, just want to write a file, just touch a file, right? It goes into the kernel of the host and is talking to a file system. So you may then say, okay, well, in Kubernetes, I know that I can attach some block devices and things like that into my container. Well, what that means is that it's happening is that there's a set of processes that happen so that container can write to that storage. What it does is it grabs the storage from that network storage device, it then attaches it to your system, and then formats it. That's the key. It formats it first on the host, and then mounts it on the host. Now, there's a big also probably some misinformation on how the container actually writes to that storage. Most people think that the container itself is the one writing to the storage, meaning that the mounting of that volume happened at the container. And that's not true. The mounting happens at the host, like I said, because it is the host that's doing everything, okay? So what that means is that the host mounts it in a certain location, /var kubelet API, some huge path. Then you say, okay, well, that's not the path that I see inside my container, right? You see a nice path that you asked it to. What happens is when Kubernetes or Docker or any type of container orchestration system, they want to bring that volume into your application so you can write. What happens is that they take that mount point and they do what's called a bind mount, okay? So it's almost like creating a new namespace, but it's still pointing to the same storage device. And they put that inside of your container as what you asked to be named. Okay, so when you say docker-v, the host path and then colon your path, that your path is the bind mount point that is doing. Okay? That makes sense? All right, cool. Any questions before I go through my next one on my list?
How do you deal with redundancy for volumes that are mounted like that?
Redundancy of volumes that are mounted. So if, let's say, for example, I have 2 containers, and those 2 containers are trying to mount the same spot. So bind mounts would, I don't know exactly how Kubernetes or the container orchestration system would do it, but it would definitely be mounted by the host, and then you can bind mount 2 locations. You can bind mount many times over. So that's just tracked by the kernel. Okay, so it's just being mounted into a new namespace. That's what it's meaning. So. But good question. Yeah.
You're the core contributor on the open source project CSI.
Yes.
Can you talk about why you started that and what that's going to do for Kubernetes?
Oh, yeah. Okay, great question. And I'll give you some money for that. All right, so let's talk about what CSI is. Does anybody know what CSI is? Oh, all right, cool. So it's kind of like CNI, but much cooler. Anyway, so what happened is that we have different container orchestration systems, and you have many ways of connecting those storage systems into those container orchestration systems. We have Docker had what's called Docker volume to be able to communicate with those systems, and then we have Kubernetes, which had what's called the internal drivers. You, as a storage vendor, I would have to write code inside Kubernetes and then be bound to the Kubernetes release cycle for my storage system to be able to be used, right? So when Kubernetes says, I want a new volume, and it wants to talk to some storage device, that command, I want a new volume, needs to go somewhere, and that code needs to be, to be able to communicate with that system. So the community got together, the community being the guys from Mesos, Docker, and Google, and got together and that created this thing called the CSI. CSI is for Container Storage Interface, and what that is a new API, a standard, and it's not a service. So I don't want to, I'll go actually talk a little bit about it after. That is not compared to Cinder. Cinder is a service in OpenStack. It has services in a database and everything like that. CSI is just a specification. And what that specification says is that all the container orchestration systems now can code to this specification as a client, and now the storage developers can code it to that specification as a driver. And now what that means is that the storage vendors can benefit by providing out-of-band drivers to already running systems. So I can, for example, Portworx, where I work, we can then deploy newer versions with newer features of our driver. Not fixes, because we never write any bugs, but features, absolutely, like snapshots and things like that. That's what comes in. Now, CSI right now is at a version 0.3, and snapshots just went in it, but it's something that is maturing, and we hope to have it in Kubernetes hopefully by the end of the year as GA. I also participate in the Kubernetes implementation team, which we actually take the CSI spec and we change Kubernetes to be able to consume storage systems that program against that API. Okay? Any questions?
Okay.
Yeah.
So if you have a containerized application, you deploy one Kubernetes environment that has certain storage drivers.
Uh-huh.
And you take that same containerized app and deploy a different Kubernetes environment with different storage drivers. What's the impact of that?
Great question. Okay, so let me just kind of reword what you just said. So if you deploy two applications on two different Kubernetes clusters, how do you know which storage to pick? So the way it works in Kubernetes is that dynamic provisioning works by a system called a storage class. And the storage class kind of defines how the storage is going to come from when you make a request for a volume, and what are the parameters for that volume. Maybe replica 3, replica 4, 2, and so on. Now, what happens is that if the administrator of that Kubernetes system has set a default value and a name, all that the application developer needs to do is that when they create a new application, make a request. A request is done by setting what's called a PVC, persistent volume claim. All they need to do is they need the name of the storage class. So if the name is the same on both clusters, then the application will run without any issues. And even though that the back end of both systems may be completely different storage systems. One may be in the cloud, like EBS, and the other one may be on-prem and be some attached volume. So does that answer your question?
No, so what if the names aren't the same? Do you have to have two different YAML for the cloud manifest?
If that is correct. If the names are not the same, then you will need to adjust it according to the storage class of what's there. Exactly. Yeah. Any other question? All right. Time to my list. All right. Let's see. What's a containerized storage system? Anybody know? All right. Okay, so let's go back and let's see how much time I have, because this one may take some time to explain. And okay, I got 50 seconds. Okay, here we go. So what that means is if you go back to the story of storage systems back to year 2000, 99, and so on, it's always been compute and storage and cluster together. So you have some type of interconnect in between. But now with Kubernetes, we're realizing that Kubernetes is now the operating system of the data center. And as such, I want to manage my apps, my applications, my network, and my storage, software-defined storage system, all through the same control plane, all through the same API. Now, to do that, I need a storage system that can act as an application, just so that Kubernetes can be able to deploy it. So for example, in Portworx, what we do is that we create our storage system, we containerize it. Now you can deploy Portworx as an application into Kubernetes, and you can deploy it using a daemon set. It goes into every one of the systems, and then takes over your local block storage on the host, and then talks back to Kubernetes and say, hey, I'm Portworx, I'm here. I can provide dynamic volumes for you. So now when applications come in with a PVC, they can come in and then storage can be provided by that new storage system that has been deployed in Kubernetes. But why would you want to do this? If you're in the cloud, you're probably thinking, I can just use EBS volumes, or I can just use the volumes from the cloud vendor. Well, some of those volumes from the cloud vendor, for example, when Kubernetes deploys your nodes, it may go across different zones, right? And what happens is those volumes are only allowed to be used in the same zone. So you have to be very careful that you can go from your app, can go from one zone to another and be pending forever because your EBS volume can only allow from one zone. But when you deploy a containerized storage system, it goes across all your nodes, and it can go from one zone to the next, and it can still attach to the storage that it was using without any issues. Okay? Any other questions? All right.
Great, thank you very much.
There's one more.
Another question?
Yeah, the last one. Yeah.
So in the demo setup, let's say,
Yeah. Microphone.
Yep.
so let's say you are running on-prem,
Yeah.
you have this daemon setup.
Yeah, Kubernetes on-prem.
Kubernetes on-prem, have your daemon set that deals with storage, and one node goes down. I will make sure you can, so all the pods will get respawn on different nodes. How you know how to get the data there and manage
All right.
those
okay.
volumes that are gone on those new pods?
Yes. So let me try to make sure I understand your question. If it doesn't matter if it's on-prem or not, what you're asking is, it's if a pod goes down, how and it comes back up in another location, how is it that the system knows that the volume, how to continue up? The application comes up and it needs the storage to continue.
Okay, my question was about on-prem because you said the demo set to expose the local volume, right?
Oh, no. Okay, so okay, let me reword that then. That's a good question, and I kind of need to reword that. The storage system takes over the block volumes that are local, like on-prem, which they cannot be moved and reattached. But what they do is they create a large pool of that across the system. And it's like, imagine it as a layer, an intelligent layer on top, where when you ask for a volume, it provides either local access or network access to them. So when a pod is at some node A, and it asks for storage, storage is provided to it from 3 different locations for replica 3, for example. And when it could be at, if it's 1,000 nodes, it could be at any of the 1,000 nodes. It would just talk to it over the network to the storage system. Or it could be on the same node as the storage system is, and it will be talking directly through the kernel.
So you are using CLI to provide.
CLI? No, it's through the kernel still. So imagine the pod is still talking to the kernel, right? It always is. It doesn't know what's going on. It's always going to the kernel. And in the kernel, there's a driver that says, oh, your volume is not here. It's on that node. So it just goes over the network, gets the data that it was looking for, and returns it. That's only when, again, that pod is running on a node that it becomes a client. It not the one with the disk. But if it was on the node with the disk, like I said, it would just get the information right there, which is good for hyper-converged applications.
Okay. One other question? Hold on a second.
I have a basic question.
Yeah.
If your database is running on a host and your apps are not on the same host, and if the host that's hosting your database goes down and your pods or your apps are still running, how do you make your apps robust until the database comes back? Or, the apps don't crash or time out or whatever.
So your apps are running as pods on many nodes, and you got your database running as a pod on another node, and that node went down. Yeah, in a different host, yeah. And node to me and host, same thing. To me, that is first is that the applications have to be capable of having failures, okay? So sometimes way in the back in early 90s, we pushed failures all the way to the storage system, right? And they became extremely expensive. And then towards like 2005 and so on, we started putting failures all the way to the application. So application is more resilient. So what I would say then is that the application, go ahead.
That's my question. Is it the app or the container? Yeah. Is it the app or the containers?
So the app needs to be resilient to know that the connection has died and to wait some time until the database comes up on some different node, because that node doesn't longer exist. And then from the storage system, it will get reattached with the same storage. So the database will still come up with all the data. Does that make sense?
So if you're an app developer, what are you supposed to look at for the comms in the cluster to detect that it's not there?
That is a great question, but that I hate to give this answer, but that depends on the database that you're using. I would use the database APIs and understand if you need to do like a retries and then with back off. So.
Okay, good question. And any more? Okay. All right.
All right.
Thank you very
Thank you,
much.
guys. Okay.